everyone. I think it's a time to start. You guys can hear me, right?
Yes.
Cool.
Yes.
Okay, I'm Flora Yu, marketing specialist from Pylontech. I will be today's moderator. So welcome you guys can join this webinar. Today we will talk about how to empower your business with commercial and industrial battery storage. And I really hope you all can gain some really valuable information from today's webinar. Now let me to introduce today's speakers. Lily Cao, she's our sales manager. She will do a bit company introduction at first. Then Victor is our field application engineer. He will have brief and give more details for our CNI BESS. At least we will have take few minutes to do the Q&A. So if you have some questions, you can ask us directly at the end of the presentation, or you can text into the chat box so we can see it. And I think Barry will not come today, so Chris Wu, he will replace Barry's place, and he's our technical support engineer, and he will help us to answer some your questions. So I think this is a really brief introduce for today's webinar, and we can really start from Lily. Lily's how you can share your screen and start your presentation. Cool.
Okay. Hi everyone. Thanks for taking your time for today's webinar. So let me give you a brief introduction of Pylontech first. Okay, so let's get started. Okay. Hey, Flora. Hello, Flora.
Hello.
Yeah. 我怎么样可以把右边的这个给它这个小窗口给它关掉呀
Here. Okay now?
No. Oh, okay. Yes. Okay,
Yeah.
it's working now. Okay, so
Good.
Okay, so let's get started. So Pylontech is a dedicated energy storage battery manufacturer and BESS solution provider. So it has committed itself to the energy storage industry since the establishment. So we took the leadership in using LFP material for energy storage, and we have been building up our R&D capabilities for the raw material, sales, management system, and the final products. So all these enable Pylontech to develop into a high-tech company with profound accumulation in technology, know-how, and experience of the industry, so that we can provide proven products and solutions to our customers. So Pylontech was established in 2009. We started with the batteries for the telecom industry. So in 2013, our first product for residential energy storage was launched. Since then, we focused on the residential market, but also take efforts to diversify our products from the residential market to C&I in 2014 and to the utility scale projects in 2015. So and now we have achieved a product portfolio covering voltage range from 12 volt to 1500-volt systems. Our production capacity is also increasing steadily. So we started with only like hundreds of megawatt hour, but achieved 1 gigawatt hour in 2018 and 1.5 gigawatt hour in 2019. So in 2020, the company achieved IPO in China, and we invested more on the capacity expansion. So up until now, we have 13.5 gigawatt hour capacities. So Pylontech is headquartered in Shanghai, China, but we are actually international market-driven company. So it has 4 factories, 2 factories in Jiangsu province, 1 factory in Hubei province, and the new facility in Anhui province. So there are 2 factories with both cells manufacturing and pack assembly, while the other 2 factories only have the pack assembly. So the total capacity is 13.5 gigawatt hour. Besides, our first factory in Europe will be in operation by end of this year, with 500 megawatt hour planned capacity in process. This factory is mainly for C&I system assembly and containerized solution integration. And we are also setting up local offices in Germany, UK, Netherlands, Spain, Italy, USA, and Japan, Australia, and Japan to provide better local business support and services to our customers. So about 95% of the company revenues is from international markets. Residential market has been our major business for past years, while we are seeing a growing demand from the C&I market since this year. Here are some highlight moments for the company. In 2020, Pylontech achieved IPO, so became a public company in China. And Pylontech has been awarded as a top residential BSS brand by IHS Research for consecutive years since 2019. And this year, we are awarded as top 1. It is also one of the top 50 Forbes China most innovative companies. Since 2021, we started the ESG journey and continue the ESG every year. So we have been taking measures to make our own contribution in this regard. For example, all of our new package of batteries will be plastic free. We are putting solar panels on our factory roof, and we are using EV trucks. As a high-tech company, Pylontech spends about 6.3% of the revenues on R&D. Now we have R&D teams for raw material, sales, system management, integration, final products, new technology, etc. It has obtained more than 238 independently developed patents, and it is qualified for UL 1642 and UL 1973 witness testing lab. So Pylontech has achieved a vertical supply chain layout. So through years of efforts, it has integrated key links of the industrial supply chain from sales, BMS, packing, and assembly, and system integration. So Pylontech products adopt a modular design because of the market features. So firstly, various capacity demands from different customers, ranging from dozens of kilowatt hour to megawatt hour. And secondly, very difficult to have one standard product to meet different requests from customers. So we adopt the modular design. Our products can cover demand from 12 volt up to 1500 volts in the market. So this modular design can help us to to simplify the products and also to meet different demands from different customers. So through many years of testing, we have achieved compatibility with most of the tier 1 inverters in the market. Here are some examples. So you can scan here just some examples, but you can scan this code, this code to get a complete set of the compatible inverters. So for batteries, safety always comes first. So our products have passed strict safety tests and obtained a very comprehensive set of certificates. For example, IEC for the European market, VDE for Germany, UL for North America, and the GIS for Japan. So Pylontech has obtained a very comprehensive set of certificates. And in 10 years, we have delivered more than 1 million systems to over 80 countries. So our product reliability is well proven in the market. So these are our products. So basically speaking, we have 12-volt portable power bank, Amberrock, RT12100 all-purpose lithium battery, 24-volt UP2500 for lead acid replacement, 48-volt residential batteries, and 48-volt for telecom backup. But today, our major topic will be the C&I solutions. Sorry. So generally speaking, we have stackable systems, rack systems, and container solutions for C&I markets. So here, Force Edge series are the stackable system. It features easier installation, mainly for the light commercial systems requiring capacities of dozens of kilowatt hour. Force H1, Force H2, they use a 3.5 kilowatt hour module, while Force H3 use a 5 kilowatt hour module. Then we have the rack system like this one. For rack systems, we have more flexible choices. So including like PowerCube X, PowerCube Edge, and PowerCube M series. So we have modules with a different capacity and voltage so that we can configure various systems. For container solutions, we have the cabinet solution Optimus, and then we have the 10 feet, 20 feet, and 40 feet solutions in which we can integrate the PCS, a transformer, STS, etc. to provide a complete solution. So for detailed product information, our technician will give a more detailed introduction later. So for me, I just give a very brief introduction here. Here you can see just some systems for our residential installations. Oh, sorry, what's wrong? And here are some container solutions we have delivered. So as you can see, our systems can be used for all kinds of solutions like peak shaving, microgrid, self-consumption, grid services. It can also be used for like time of use, energy cost management, demand management, etc. So that's all for the company introduction. Our technician will give more detailed introduction on our C&I products and solutions. So thank you.
Okay. Thank you, Lily. So I think I will share.
Okay, let me. Okay.
Okay, thank you.
Thank you,
In a
Victor.
second,
yeah.
I'm gonna share my screen. You can see it now?
Yes.
Okay, thank you, Lily, so much for your time. So I'm Victor San Roman. I'm a field applications engineer for Pylontech. So for this part, after the introduction of the company, I will talk about some of our CNI big solutions for storage systems. We will see some application scenarios. Lily has just spoke a little bit about those. So I will mention a little bit like more to tell you more what we can do with this type of solutions. And then we can go to some specific products. We have a very big catalog, but we will talk about some of specific products. And if you have any questions, you can ask. So we will tell you what kind of applications we can solve, and also some specific modules that we work on. And also we will talk about some actual projects that are working right now around the world that we have with different applications. So let's start. Okay, so first, I think this is skipping it. So first, we have some scenarios, as you can see here in screen. We have many applications. It can be self-consumption, it can be demand charge, it can be microgrid, it can be EV charge station, it can be backup, it can be peak shaving, off-grid, B2G, frequency integration, and renewable regulation. So we will talk specific of these scenarios, but as you can see, there are many applications that we can do with the storage solutions. Of course, integrating PCS, some other times maybe a transformer, but it doesn't matter. We can solve any of these applications for your customers. So we can help them in their solution, the SIG they need. Okay, so first application we have is grid service, in which maybe our customer needs to keep the grid in, let's say, in a safe mode, that maybe can have some variations. It can go up, it can go down, and then their end customers can have some issues with the grid. So for this type of problem, we can have a battery energy storage system that can provide power and to detect maybe if there's some variation in the grid. Maybe it can go up, it can go down in terms of frequency. So what the battery will do is that it will charge the battery when the grid is, let's say, abundant, when we have many energy, and it will be waiting until maybe the grid will have some low voltage or some low frequency, and then immediately the PCS will discharge the battery. It will go to step-up transformer because maybe it will need it. Maybe the voltage from the PCS won't be the exact same as in the grid, so maybe it will have to step up or step down, but it will discharge the batteries and it will go to the And also we'll tell our batteries what to do. We'll tell them if they need to charge or if they need to discharge. So in this scenario, we can do this. Of course, maybe as this is a grid service, we will need a bigger system. So for this case, as an example, we have three different containers, which each one with its own PCS and its own transformer. So of course, this can change depending on how big we need the system, but this is one scenario we can work. Second one is frequency regulation, that it's a little bit similar, but the main difference with this one is that for this is not for grid, it's for consumption, for loads of our end customer. So maybe our customer tell us that maybe, I don't know, it's a factory, it's a hospital, it's something like that, and they say, I need to maintain my consumption as stable as possible because maybe I have some issues with the grid sometimes. Sometimes maybe the voltage goes so low or the frequency changes, and I have equipment that I need to keep working on. So for this scenario, it will be similar, that we will have the BSS expecting to see if there's any changes in the voltage or in the frequency of the loads. Of course, through the EMS, I will read all of these measures and to see if we need to discharge the batteries. But in the scenario that we have plenty of energy and there's no issue, the batteries will be just charged and will be maintaining the charge and the voltage, expecting to have some problems, some issue with the grid, and then they will discharge. Of course, in this solution, we can also aggregate a generator like we have here in the diagram. So maybe it can be like second option in the case that maybe, I don't know, the batteries are completely discharged, we still have some issues with the grid. Maybe in that case, the EMS can tell the generator to discharge, so also to maintain the frequency. So we have derived some diagrams that we see that in the green lines, it will be the batteries, at least in the bottom one, that will be discharging to maintain frequency stable. It also depends, of course, the frequency. We can have 50 hertz or 60 hertz, depending the country, but it doesn't matter. The first thing that we need to solve here is to maintain the voltage and the frequency of our system. Then we have the microgrid and off-grid. So for this one, maybe we have a complete system that will need to be loaded to have energy all time, and we can have grid or we cannot have it, doesn't matter. We still will need the battery energy storage solution, the PCS, and different sources. It can be PV energy, it can be a generator, whatever. So for this scenario, let's say that we have solar, and how the system will work is that when solar is sufficient, solar will charge the batteries and also will power the load. So maybe let's say that solar goes weak because it's getting late or maybe it's cloudy. So now the battery will get in the system and will start to discharge and also go to the loads. So it will always expect that the solar production goes down. So maybe if we go at night where there's no any solar production, the battery will completely start to discharge and go to the loads. So if the battery goes in low mode and will still not have solar, the generator, if we have one in our system, can go to power the loads. And then when the solar production goes up again, we will start to power the loads and also to charge the batteries. So in this scenario, the first priority always will be the loads, but we can change the priority of batteries, of grid if we have grid, and also from generator. Then we have the backup solution, that it's a very common one. So for this one, we need to maintain the loads power all the time. So in this scenario, when we have a solar production, solar will go to loads and also will charge the batteries. So if solar was weak and we want to configure it that way, batteries can also power the loads. But let's say that maybe we just want batteries to discharge when we have some grid failure. So let's say that the batteries will be in standby mode all the time, but grid goes off. And also maybe we can have the scenario when we don't have any solar production. So let's say that we just have the grid and we just have the batteries. So what will happen is that the grid will charge the batteries and the batteries will keep charged. But if the grid fails, if the grid goes off, then the battery immediately will enter the system and will power the loads. But in this scenario, we can also have a generator. We can also have a solar production. It doesn't matter, but the important part here is that we always have the batteries to power the loads in any case of failure. Of course, we can have the EMS. The EMS can help us to make work the solar, the generator, the batteries, to know the grid status. But the most important part is to maintain powering the loads. So that's the first priority for this type of system. Now, peak shifting or peak shaving is the scenario when we have some consumptions at time of the day that goes up, and maybe the electric company will charge you for these peaks. So what we try to do with this type of systems is to not make sure the batteries can discharge when we have some specific loads go up. So let's say that we want to consume from the grid just, 50 kilowatts. But if we have some peaks of 60, 75, let's say, we will configure the batteries through the EMS to discharge immediately when they see that the consumption goes up. So we will maintain, in this case, the 50 kilowatts from the grid, but the extra kilowatts can come from the battery. So doing this, we will, let's say, maintain the consumption from the grid, and we won't be charged for these peaks. It will go through the battery. And of course, in this case, we can also have solar, we can also have generator, but the main focus for this one is to power those peaks, and we can do it in any power. We can do it 50, 100, doesn't matter. We can adapt to your needs, but this is the main solution that we want to try to solve. Then we can have the off-grid, let's say, large scale. So it's not that different from the past one that we saw, but in this case, as you can see, we can have many battery energy storage solutions and many solar production. But in this case, it will be the same, just have more products, have more models. Maybe the EMS will have to handle more concepts, but the logic will maintain the same. When we have solar production, we can go to charge the power loads and also charge the batteries. So maybe when the solar production goes down or it's at night, the batteries can get in the system. And for this system, of course, we always have to power the loads. And if there's if the system also has generator, maybe the generator can be the third priority. So we don't have solar production, we don't have batteries because they go to a low SOC. Then we can make sure the generator starts and goes to power the loads. And also, if we want, generator can also help to charge the batteries in some important scenario. Also, always we do this through the EMS. EMS is the one that gives instructions to all the concepts. It gives instructions to solar production, to energy solution, and to generator. But we can adapt it as you need in terms of power or in terms of storage. We can go as big as you want. Now we have also the EV charge stations, and in which we can also have batteries to help to charge the vehicles. So we have many scenarios with this. We can have the grid, and the grid also can have solar, and we can go to the EV charge station. but we can also have some specific stations that can have batteries. So maybe we can use batteries to charge the vehicle when there's no solar production, or maybe for some scenarios when the grid goes off, the batteries can go and charge the vehicle in the case that we need. Or maybe we can also have this station off grid, like we don't have any grid in this case, so maybe solar can be first priority, and then batteries can be second one. So we can adapt this anyway. We can have some stations that just work with the grid. We can have some stations that work with batteries. And of course, we can have the EMS telling the system what is happening and what it needs to do. If it has to go through solar production, if it has to go through batteries, or if it has to go to grid. Doesn't matter. We can have grid, we can have solar, we cannot have them, but the batteries will work as we tell them. It can be for some specific stations, or it can be for the whole station. And also we can have the renewable integration, in which we can work with solar production as we have spoke in the past, or also we can have some wind eolic production. It doesn't matter, we can have them in the system. And in this case, we can do many applications. So we can maybe power the grid to help the grid to maintain voltage, moderate frequency. We can power some loads. So in this case of projects, we can do many solutions. So in this case, we can say that battery can charge when the solar is abundant, and to discharge maybe when there's no solar, or when solar is variable, maybe it's cloudy day. But as well, the main focus will try to maintain the frequency and maintain the voltage. So there's many cases that we can use, but we can do like integration with solar and also with wind and also generator. Doesn't matter, we can do it anyway. And also here we can see the many solutions that we can do. We can go to power station. We can use, as I said, wind power, or we can do solar power, and we can go to charge loads. We can do for data centers, that they are very important because they need power all the time. They cannot go off. We can do it for factories that also need to maintain production. We can do it to hospitals that also need the power all the time to keep working, to businesses. So we have many customers or many solutions that we can provide. And in all of those, we can add a battery solution, and we can go as big as you want, or we can still maintain it low. So the only difference is how many modules we can use, and we will see some scenarios with some products that we can go with many applications, and also that we can have a different size. How big your project needs to be. And also for the applications, maybe it's an off-grid project, it's not that big, we can have small battery size, or maybe we need to help the grid to maintain stability. So maybe in this case, we will need a container. So we will need for you to tell us what's your need, how much power do you need, how much storage do you need, and we can develop or design a project that goes and helps your needs. So we can start from very few battery modules going up to many containers. Also, very important is the high compatibility. So our BMS has a very adaptable range, so we can go with many solutions. Maybe you have a PCS from different provider. So maybe we just can give you the storage solution, but the good part is that we have high compatibility, so you can talk to us and we can see if our system can work with your PCS or your EMS. Doesn't have any issue. But the important part is that we have high compatibility with many solutions. Also in the low voltage solutions, we have many capabilities as you see before with Lily. So there's no problem in that part. Also, we always working with the R&D department to have new products, to have better solutions for our products that are working right now. Also to have the warranties, also to have certifications, so we can help you to work in any market that you need to work, and also to maintain the good performance of the project. So we are always looking for new designs, for new products, or for better efficiency of our own products. So we are always working in this. Let's talk a little bit about some of our solutions. These are not all. We have, as I said, many products. We have many solutions, but we will try to show you some so you can see what type of solutions we have. So in this case is the Optimus cabinet. This can have a battery capacity from 100 kilowatt hours to 400 kilowatt hours. We can have from 2 to 3 hours for backup. Also, the PCS power range can go from 30 kilowatts to 200. And in this case, we can do EMS. With the EMS, we can do self-consumption, we can do demand response, we can do microgrid, and also we will have remote control. In this product, we have protection IP65, so the cabinet can protect the batteries, and also IP54 for the PCS. So we can have the cabinet with the PCS inside, or it can be outside. So it will depend on what you need. So also we have the fire extinguisher system for any problems that can happen. So we can be safe that the batteries will not burn or whatever. So this, let's say, it's medium small solutions that we can have with our batteries. But now let's talk about bigger solutions. Let's talk about the container solutions. So in this, that is a 20-feet container, we have batteries. We have also the HVAC for maintaining the temperature, the fire suppression system. We have also the EMS inside. We have also the PCS inside. So for this type of solution, we can have a maintenance inside the container. So you can see we have some space, so the installer or whatever can get in the container and can go to any of the part of the solutions, can go to the batteries, to the EMS, and to make some maintenance, and to also make commissioning, whatever. But for this type of solution, we have this container that has walk-in maintainable. But we also have bigger containers. In this case, it's a 40-feet container that is full battery. So in this case, we cannot get inside the container, but the containers has some front doors that we can open, and we can go to the batteries and to make some commissioning or to do any type of maintenance that we need. So for this scenario is for the M5 battery that we will talk a little bit later. So in this case, the maintenance will be outside, but we also still have the HVAC for maintaining the temperature in both sides of the container. We also have the DC confluence cabinet for the batteries to get discharged, and also we have the fire suppression system. So this is a bigger container, but it's for solutions that need more storage. That is very big solution for storage. So we can work with this type of containers that has full battery. Also, an important part is that if you work with our container solutions, we have a pre-engineer. So we are pre-installed the batteries also in factory. So when you receive the container, you can have the batteries completely installed. Maybe you just need to do some connections to the batteries, but also we have it maybe configured before help you to have it this as quick as you need. And also that we can do the full integrations inside the container, as you saw before, where we can have the batteries, the HVAC, where we can have also the PCS, the EMS. So if you have any scenario where you need everything inside a container because it's maybe it's off-grid, maybe it's very isolated, the system, maybe it's very far from city and you don't have any construction inside, maybe we can work this with the container that can save us some effort and some costs. So we have other solutions. So in this case is the Power Cube 20 feet with the M2 battery. The battery that we will be working with, this one is the M2 battery. And for this product, we can have the voltage going up from 680 volts to 900 approximately. For this type of scenario, we can do up to 1C to have the discharge battery in 1 hour. And in this system, we can have the capacity of around 1.4 megawatt hour. And also you have there the dimensions. And with this type of container, we can have the very big range in temperature for working, going from minus 20 degrees up to 60. And for the communication of this type of product, we have the CAN bus and have the Modbus and the IP. Also, we have the safety certificate for IEC and UN. So this is some solution that we have that is for around 1.4 megawatt hour. So for these solutions, we will be working with the M2 batteries, that each module is for 5.68 kilowatt hour, and it has the main controller, the S1000 M2A controller. So this is the product that we will be working in this case for this container. Then we have this 20 feet container as well, but it's for the M5, that is our biggest battery that we have. That for this system, we can have the voltage from 1000 to 1500 volts. Also, this can go for 0.5 C. So maybe we can have the discharge for 2 hours, and the capacity of this container can run from 2.5 megawatt hour to 2.6 megawatt hour. Also, the temperature will be similar because the containers maybe can go bigger or smaller, but they will maintain same specifics. So the temperature stays the same. And the communication in this one is RS485 CAN and also Ethernet. And for this one, we have the UL certifications, we have the IEC, and we have others like the UN, as we've said before. But for this one, the battery module is bigger, is the M5 battery, that this one is 15.36 kilowatt hour, is like 3 times the M2. And also we have the main controller that can work from 0 to 1500 volts. So this is a bigger module for bigger solutions that maybe you will need. Also, we have the 40 feet container with the M2 battery, when the voltage will be similar. We will have from 680 to maybe around 900. It can be also 1C for 1 hour, but in this case, it's double. So we have almost 3 megawatt hour, exactly 2.9 megawatt hour for battery. So as you can see, it's maybe the same as in the first solution, maybe just double, just the double of size. So the first solution that we saw with the M2 battery was 20 feet container. So in this case, it's, let's say 40 feet container. But the only thing that will change is the capacity of the system. So it will have more batteries and more storage. But the other specifics will still the same. We have the same certificates, and we have the same communications as in the past solution. Also with the M5, that we have the same voltage, went from 1000 to 1500, it will be still 0.5 C, and in this case the capacity is as well going up to 5.2 megawatt hours. So it will just going bigger with more container and with more batteries. So we can have bigger storage solution, but the temperature will still the same, minus 20 to 60. Communications will be the same. Also the certifications. And of course, for these two, is the same battery modules that we talked before. It can be the M2, M5. Also, we have the M1 and M3. But in this case, we just wanted to talk about these two for this specific webinar. But in the future, we can talk maybe about other modules that we have. But the main difference is the capacities. But for these two are some of our biggest modules that we have. So you can see that you can have very big storage solution. And we will talk about a little bit of our some case studies that we have before. So we have this project. Oh, this is changing very fast. Give me a second. It doesn't stay. So well, we have this in Middle East. Is for self-consumption. It can have the generator. I know what's happening. Give me a second. I will try to show it this way because I don't know why it's changing so fast. So we have this project in Europe is for 400 kilowatts with 432 kilowatt hours. This was installed this year. Is for self-consumption, and we can also help the grid, and we have also the storage solution. So this is mostly for the customer to have consumptions through the batteries. And so in this case, maybe he can use the batteries in nighttime, or maybe when there's some issues with the grid, or in any time of the day that he needs. Also, we have this in Middle East. It's also for self-consumption, but this has integrated a generator. This one's bigger, is for 630 kilowatts and 613 kilowatt hours. And this was installed last year. So this is very similar, just bigger, and this is for the batteries to be discharged in 1 hour. We have this one also in Europe, is for self-consumption. It's from 312 kilowatts with 435 kilowatt hours. It was installed last year. Also, we have this that is bigger, is for grid service, the solution that we spoke in first place. This for 1 megawatt for power and 2 megawatt hour for storage. This was installed also last year. We have also this one that is for 1 megawatt, 1.5 megawatt hour. This was installed in 2021. This is a complete microgrid solution where we have the solar production. We have also the BSS and also a generator. We have this one also in Africa. This is a microgrid as well. It's for self-consumption. It has batteries and generator, and this is for 375 kilowatts and 756 kilowatt hour. We have this in Asia. This is a bigger one. This is a complete off-grid system where we have solar production, generator, and battery energy storage solution. This is for 1.2 megawatt power, 2.65 megawatt hours. This was installed in 2020. This one in America is also a microgrid self-consumption project for 500 kilowatts, 750 kilowatt hours. This was also installed in 2020. This in America for 1 megawatt, 2 megawatt hours, also in 2020. This is for grid service. This is in Antarctica. This is 132 kilowatt hour. This is also self-consumption that has also a PV system, wind system, generator, and battery energy sources. This is a complete microgrid. This is out in Oceania. This is just for peak shaving. The smaller one is 90 kilowatts, 260 kilowatt hour. It was installed in 2018. This in Asia, also 1 megawatt, 2 megawatt hour with solar, with the grid, the battery energy storage solution. This is also for self-consumption, and this was installed as well in 2020. This in Asia, microgrid, 2019. This is for 500 kilowatt, 833 kilowatt hours. This is for complete UPS, just for backup, 1 megawatt power, 2 megawatt hours batteries. It was installed also in 2020. This is one of the biggest ones. In Asia, 1.5 megawatt, 2.5 megawatt hours. It also has the grid, the PV, and also the BSS. And also the last one, this in Asia, microgrid for self-consumption, 250 kilowatts, 540 kilowatt hours, also with solar, with generator, and this was installed back in 2017. So this is all the solutions that we have, and also you have here the emails for Lily and for Barry if you want to contact with them. Also, we have the QR for our page, and I don't know if we have any questions, but thanks for your time.
Yeah, thanks, Victor. And I do found some questions in the chat, and I will answer them one by one. So first about the air-cooled system or liquid cooling system. So currently our container solution are air-cooled system, because our R&D team consider an air-cooled system and liquid cooling are they have advantages and disadvantages. So for air-cooled system, they are much more easy to do maintenance, and for liquid cooling, the cooling liquid cannot use for 10 years or 5 years. Every 2 years, they need to be replaced, and during the maintenance, the system will be shut down, and the liquid will be poured out and re-put in. So currently we are still doing air-cooled system, and based on our design and our tests in the lab, for example, in our PowerCube M5 container, the temperature difference in the whole container between battery racks are around 4 to 6 degrees Celsius, and we believe this still a good performance for the temperature in the container. So of course our team are also to observe if liquid cooling is necessary for our container solution in the future for larger containers and for larger energy density. This problem will be discussed. And the second question is about fire suppression. And in the container, we will have firefighting gas and also the pipes that can cover all the battery stack. And of course, the whole container will be affected or will be protected by the firefighting system. And the next question about H48050, and this battery system is for residential or also for light commercial. So in one rack there can be up to 20 modules. There can be up to 20 modules, and per module can provide 2.4 kilowatt hour. So that will be 48 kilowatt hour in one rack. And this system can also expand to 6 groups. So there will be around 300 kilowatt hour. But if the customer wants a 400 to 1 megawatt hour system, we will recommend them to use PowerCube M1 or larger battery modules, not PowerCube X series. Next question is about PCS. So about the PCS outputs, for example, in our M5 solution, and the system will have 1 megawatt PCS and 2 megawatt hour battery modules. And with 1 megawatt PCS, there are two 5 kilowatt PCS, and the output will be 400 volts. And if the customer wants a larger AC output, a transformer will be needed, or a substation will be needed, and we will recommend the customer to choose local supplier or purchase the transformer from a local country. And about datasheet. Yes, so for like CNI solutions or for CNI solutions, usually we will have a checklist to send to the customer and ask them to input the demand, like which scenario they want to use, and how large the battery capacity, how large the PCS power will need. And then our technical team will discuss with the customer about the solution, and then we will give out a solution with a BOM that can include the EMS and PCS inside, and then the customer can check the datasheet and discuss further if they think this system is suitable for them, or the system or there's still something need to be modified. And about the sodium batteries. So they are still in research. We do have some products that are being internal test, but we currently the sodium ion batteries are not available for the whole market. EMS solution. Yes, the EMS, we can provide our own EMS, like a local controller in a cabinet to guide the battery or guide the PCS when to charge, when to discharge. Yeah, the next question. So energy producers, for energy producers, I believe you are referring to solar farm or wind farm, like those green energy station. And in that case, the batteries are used and can be used for self-use, restore the energy from the solar panels or the wind station. And when the network, when the grid needs the power, the energy station can output the power directly. And when the grid they do not need the power currently, our battery systems can restore the power from the station and respond to the grid demand when the grid sends the request. Yes. So about our residential or a light commercial solution, we cooperate with a local distributor, and they will offer the installation and commissioning. And for our container solution or cabinet solution, we will finish the installation on our factory. And before the system was sending out, the communication inside, the power cable connection inside, and also the debug have already been done. And the customer at the site, they only need to like connect the AC output or the DC input to the PCS. That will be easy for our customer to use the system directly. So about after sales service and warranty. So for our residential battery, there will be like 10 years warranty, and for nice solution, the standard warranty year will be 7 years, and this warranty can be discussed if the customer wants a longer want to expand their warranty. It's also okay because the design life of our CNI system are 15 years. So customer checklist. Yeah, so if you have a CNI solution demand, you can send email to Lily or to Barry, and then they with your demand, and we can send you the checklist. Then you can tick on the checklist and reply to us, and we will help you to design the solution. Do we have other questions? Yes, I believe essentially all the questions have been answered. Yeah.
Yeah. Thank you so much, Barry. Chris.
Yeah, no problem.
So, Flora, I think this is all the questions.
I found you answered all the questions, which is nice. And I also shared Lily and Barry's email and our company's website to the chat list, so you can save it. If you have another demands or want to know more, you can just contact with them or just find some information on our websites. So I think this will be all today's webinar, and thank you for all attendees and our speakers. Thank you.
Thank you, guys.
See you
so much
guys.
for your time.
Bye-bye.
Bye-bye.